Good afternoon, MI Islanders. This is Miss Griggs here to do the rate of heat transfer demo. This is the first demo in your ceramics unit journal. Okay, you can find it on Schoology. You can print it out. You may have picked up a copy at school. But first thing we're going to be doing is we're going to be drawing what we have in front of us. Okay. So I'm going to go over what we have in front of you real quick, and then I'm going to show you the diagram that you can draw. So we have two rods here. One is a silvery looking rod. One is a tannish white rod. Okay. They're made up of two different materials. We have a metal rod and a ceramic rod. And then on top we have some candles. Okay. They're very delicately put up there. And I'm going to show you how I put those up there here in a minute. But first, once you've got that worksheet handed out, whether you printed it out, you're doing it digitally, we're going to draw this on number 1, okay? If you want, you can pause the video, but I'm going to go over it here and tell you what you're drawing. So we have our stands on the sides, clamping in the rods. All right, our first rod is our metal rod, which is made up of aluminum, Al. All right, then we have our white ceramic rod, which is made of alumina. Okay, now alumina is not aluminum, it is aluminum with oxygen in it. And the chemical formula is Al2O3, and the chemical name is aluminum oxide. And then on top we have some candles. Now what we're gonna do is we're gonna take our lovely propane torch, because you know how much Miss Griggs loves to play with fire, and we're going to heat up where the two rods meet in the middle, right there, okay? Now, when we heat this up, what we're going to be expecting to happen is we want to see how the heat radiates between the materials or through the materials. Now, what we're going to be looking for are the candles to be falling off, all right? So, on question number 2, it asks, which rod do you think will transfer the heat the fastest? Do you think it's going to be the aluminum rod, or do you think it's going to be the ceramic alumina rod, okay, which is aluminum oxide? All right, so I'm going to show you real quick how I put these candles on there. You know how Miss Griggs is always saying that this class requires a lot of finesse. Well, this is one of those times where finesse really does matter, because it's kind of hard to get these candles on here without burning yourself. Yay. Okay, got it. So you've got your drawing done. You've answered question number 2. Which rod do you think will transfer the heat fastest? Either A, aluminum, or B, aluminum oxide. Again, this side is the aluminum metal rod, and this side is the alumina, which is aluminum oxide, white ceramic rod, okay? And we're gonna use our wonderful propane torch and heat the center of where the two rods are meeting. All right, so we're gonna do that on a low heat. What you're gonna be looking for is which candles fall off first. We're going to expect these first two that are closest to the flame to fall off, and then succession down the rod. All right, so let's get this torch going. All right, we're going to do that on kind of a low heat. Oh, what did I forget to do? Safety first, goggles. All right. Okay, so I'm going to heat the center of, center of the rod right there. Okay, and again, what we're looking for is the candles to fall off and which candles or metal are falling off first. Okay, so we have our first candle fell off on the metal aluminum rod that was closest to the center. Okay, and on my side, oh, there goes another one on the metal side. And what I'm seeing on my side is I see a little bit of red where the flame is heating up the ceramic. The metal is not heating up red hot like the ceramic is. On my side, you can see it's starting to get red hot. You might be able to see it kind of underneath. Can you see that? Getting red hot? On my side, it's getting red hot on the ceramic, but not so red hot on the metal. Okay, one more of the metal candles has fallen off. Okay, we're getting a little smoke because that's some of the wax from the candles burning off on the metal side. Not much happening on the ceramic aluminum oxide side. Let's see if we can get that last candle to fall off. Oh, we're getting one of the, okay, finally one, okay, one of the aluminum oxide has fallen off. Oh, and there goes the last. All right, I'm gonna try and do the torch this way so you can see how that ceramic is heating up to be red hot. Can you see that there?
Yeah.
Okay. All right, and still nothing happening to these candles here. So what I'm gonna do real quick is I'm gonna touch in between the candles. This is cool to the touch, cool to the touch, cool to the touch right here, right next to where that one fell off. I'm gonna do that on this side. Okay, down here, ooh, that's really warm right there. Yeah, not gonna touch that anymore because that side is really hot. All right, this side is very cool. So what that means, what they're showing us, the rod that transferred the heat the fastest was the metal aluminum rod, which is what we expect, right? Because we know that metal transfers heat the best. Now ceramics, they absorb heat, but they don't transfer heat very well. That's why we use ceramics in things like glass or like glassware, your dishes, things like that you cook in, stoneware, things like that, what you cook your pizza on in the oven at home. It does hold the heat though, because if I'm not going to touch it, but I'm going to put my back of my hand, you know, that's what proper safety. It is still very warm right where that flame was heating it up very closely, where it was getting red hot. I can still feel the heat radiating off because it absorbs the heat, but it doesn't transfer the heat, okay? So some other observations and thoughts that we may have seen is that the candles fell off of the aluminum from the inside out, so we had the heat radiating from the center out, all right? The candles didn't fall off of the aluminum rod. Well, we had one fall off, but the other one stayed on, which means that the ceramics don't transfer heat, and they're not very conductive, okay? It's because they have those, that's just one of those properties of ceramics. They're non-conductive, and they don't transfer heat very well. So under the interpretation questions, it says, which material transfers the heat fast? A, metals, or B, ceramics? You answer that question for yourself. Fill it out on the Schoology quiz, and that'll be your grade. All right, hint, it was this one. Bye, guys.